Hello, my name is Tony Botting and I'm a simulation specialist at GoEngineer. In this video we'll discuss how to generate hoop and radial stress and displacement plots. Suppose we have this cylinder that is loaded with an internal pressure. We expect the hoop stress to be uniform in distribution and therefore uniform in color on the stress plot. However, when you plot a stress component other than von Mises stress, such as Sy, you see a non-uniform color distribution. To interpret the plot, you must draw lines parallel to the coordinate axes and see that on the horizontal axis, Sy represents hoop stress at particular locations that cross the line on each side of the model. On the vertical axis, you see that Sy represents radial stress at particular locations that cross the vertical line. This interpretation is confusing to present to most people. It is better to utilize the natural coordinates of the structure to show the hoop stress and radial stress components. To do this, you can reference an axis down the center of the cylindrical shape when you plot the result component. We want to maximize use of available computing resources, so we develop a configuration using 1/4 of the model. We place symmetry displacement restraints, or what are called roller slider fixtures, on the cut surfaces. After we run the analysis, we generate the default von Mises stress plot. However, your client needs to know the hoop and radial stress components in the model. To do this, define a new stress plot. In the drop-down, pick Sx for radial component of stress, and pick the SolidWorks axis as a reference. Simulation now shows us the effect of picking the axis. It sets up a cylindrical coordinate system shown by the translucent green cylinder with two axes, R for radial and Z for axial. The hoop direction is around the circumference. This is the radial stress. You can see areas in the model under radial tension are colored red with positive values in the legend. Areas in the model under radial compression start with a light green color and transition to blue. They have a negative sign in the legend. Now let's plot the hoop component. We define a new plot and choose the Sy component for the stress, and pick the axis for reference. You can see the hoop stress is all in tension. It's highest in tension on the inside diameter of the component. The same goes for displacements. Right-click on the results folder and define a new displacement plot. This time we pick Ux for the radial component. In Advanced Options panel, we pick the referenced axis. Notice the green reference cylinder again and the red arrow labeled R for radial. You can see the legend shows all positive numbers, so everything is expanding radially outward. The small opening expands more than the larger opening at the opposite end. Now we do the same for the hoop displacement, represented by Uy. We see effectively zero values as expected by examining the legend. The multiple colored areas are a result of round-off error, but are effectively zero too. To review the results association when you reference a SolidWorks axis, Sx and Ux are the radial stress and radial displacement components, Sy and Uy are the hoop, circumferential, or tangential components of stress and displacement, and Sz and Uz are the axial components. In this video we discussed how to generate hoop and radial stress and displacement plots.